So how exactly do we know how deep the ocean floor is? If you remember about the submarine that exploded trying to explore around the Titanic, when we get deep enough in our oceans, the pressure is just way too great for humans to survive, even inside of a submarine. So this video is going to focus on how we know exactly how deep our ocean is and how it changes in different places. And this is all a term called bathymetry. Bathymetry is just a way in which we map our oceans and how deep they are and what the shape and the topography and elevation of the seafloor look like. And there are lots of different ways that we can do this. Some are really low technology that we've been doing for a century, others really high tech that we're using satellites and not even going to the ocean itself. But the one thing that we've used the longest in order to learn about the bathymetry, again the depth and the shape of our seafloor, is through sonar. And sonar works through echo sound. It's going to be very similar to the way a bat flies around. And sonar was invented over 100 years ago in the 1920s. And this is the main way that we measure the depth from the surface oceans all the way down to the seafloor. And that's because the sonar is going to release a sound from the instrument itself. It's going to go through the water all the way to the seafloor. And when it hits the seafloor, it's going to reflect off the surface back towards the instrument. And this is just going to determine how long it takes. The longer it takes for that signal to come back, the deeper the water is. If it only takes a few seconds, it might be shallow water. If it takes a few minutes, it's going to be a lot deeper until we hit the seafloor. Looking at the bottom of our seafloor, we're going to have three major types of topography, where the shape and depth of our seafloor is going to change. We're going to have continental margins, and our seafloor, and then our mid-ocean ridges. So our continental margins, if we're looking at A, it's going to be this very light blue area off the coast of North America. Our continental margins are still continental rock, even though they're underwater in the oceans. So this is not yet oceanic crust. It's still continental because it's made out of felsic materials like granite. So generally we see our continental margins are going to have a very steep slope. We're going to start off very high in elevation and then very quickly go to a lower depth within our seafloor until we reach our deep sea or our deep ocean basins. And again, a basin is kind of bowl-shaped. It's deepest in the middle, and it's also relatively flat along the bottom of our basins. But in the middle of each ocean, we have a mid-ocean ridge, where we're going to see that the seafloor is going to get much closer to the surface. And this is due to the fact that our mid-ocean ridges form at divergent plate boundaries, where we have two plates that are separating and new crust is forming between them. This new crust is really hot, so it's going to expand out, leading to a really high elevation, very similar to a mountain in the middle of our oceans. But if we continue along this line from A to B, past our mid-ocean ridge, after we get past the ridge, that really high elevation, we're going to go back into another deep ocean basin where it's deep and relatively smooth along the bottom, and then finally end at a continental margin as we're getting closer to the edge of that continent.